All right, so today we're doing geometric sequences, and we're going to be finding the constant ratio of a geometric sequence. We're also going to be finding sums, and then we're going to determine if the series converges or diverges. So in a geometric sequence, the ratio of successive terms is constant. Remember for the arithmetic, it was the first differences were constant. So if they have a common ratio, it can't be 1, as if you're just multiplying by 1, you're going to get the same thing. And geometric sequences are exponential. So just like we had an equation for the arithmetic, we can use this equation for geometric. So this is to find a term. A sub n is equal to a sub 1 times r to the n minus 1. Okay, and you might remember, you don't have to write this one down, but remember how we talked about like y equals a times b to the x? Okay, where a was the y-intercept. This is just another form of this, except instead of y, you have a sub n. Because it's the first term, to find the y-intercept, what would you plug in to find that term? What do you plug in to find the y-intercept? 0, right? Okay, to find a sub 1, we plug in a 1. So instead of e to the x power, this would be like to the x minus 1 type of thing. Okay, except instead we're using the ratio and we're using the value of n. Alright, so they do have a similar setup there. Okay, so in your first example, it says the nth term is given, but I need to actually give that to you. And then we're going to find the first 5 terms. You're going to find the common ratio, and then we are going to graph those terms. Okay, so the sequence will be given to you. A sub n equals 2, 4 to the n minus 1. So based on that, you can do part A. You can find a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So just like we did with the arithmetic, you're just going to be plugging in those values. So if you want to find the first term, we're plugging in 1. The second term, we plug in 2. Okay, and a lot of these you can do with mental math. Just remember, anything to the 0 power is what? So what's 4 to the 0? 1. 1 times 2? 2. Okay, and then for a sub 2, 2 times 4 to the first. 4 squared. Okay, and then you can see what your common ratio is because it's in that form. What's in the space of r? Yeah, so 4 is your common ratio. Okay, so you could do just 32 times 4. Do you know what 32 times 2 is? 64, so 64 times 2, 128. Okay, and then 128 times 2, 256, 256. Alright, so if you have your equation in this form, you can pick out the ratio right away. You can see that it's 4. They're not always going to have n minus 1 as an exponent. You might just have n. So you do need to just be aware of that. So if it's not in that form, you can always see the a2 divided by the a1. Okay, and if it's given in that form, you can just pick that out right away. Okay, and then we remember from the other day how to generate those points. So whatever you plug in, if you plug in 1, your output's 2. You plug plug in 2, my output is 8, 332, 4, 128, 512. Okay, so I can equal my x by 1s. Okay, and we do need to make it up to the 512, so let's go by 100. And then our next one will just be off the grid a little bit. Now, remember, this has the domain of the counting numbers, and you're not going to be connecting your points. So 1, 2 is very close to that line. 2, 8 is also very close. 52 is a little more. 4, 128. 512. Okay, so we are not going to connect those. I am going to show you on the smartboard though, if you want to connect them, they would look like an exponential function. Oops, I missed the last one. Alright, so it is going to fit that form that we learned about in chapter 4 this week. Alright, now we have to determine whether each sequence is geometric. So we already got this and found the concept so far. Okay, so in example 2, we're going to determine whether it's geometric, and if it is, we just have to identify the R value. Okay, so we know that the ratio is the A2 over the A1, but that's going to work with any two of your terms if you put the second one over the first one. So when you find your value of R, you can do A2 over A1 is 1/5. If you have your calculator for these, you could just multiply. 5 times a fifth is 1. 1 times a fifth, you get 0.2. 0.2 times a fifth, you get 0.4. Okay, you can also set this up to make sure that the ratio of A2 over A1 is equal to A3 over A2, and that has to be equal to A4 over A3. Okay, so when I say that pattern continues, I just mean that previous term, or the term over the previous term over the previous term. Okay, so we have 1/5, we have 0.2 over 1, and we have 0.04 over 0.2. Okay, so this one is 1/5. Let's see if this converts. So for 0.2, if you want to convert that, 0.2 divided by 1 is 0.2. That would be 2/10 because it's in the tenths place. That reduces to 1/5, so that does check out. So I'm going to keep that over 1 for now. And then the 0.04 over 0.2, if you multiply each of those by 100, so that you don't have any more decimals, you're going to have 4 over 20, and that reduces to 1/5. So, yes, they are all the same, and our common ratio is 1/5. Okay, and like I said, if you have your calculator, once you do the A2 over A1, you can just multiply to see if those work out. Okay, if you don't have your calculator, you'll have to set up those ratios. Alright, so let's set up the ratios for part B. So I have 90 over 180, 60 over 90, and 15 over 60. Okay, so if I reduce, I have 1/2. Okay, 3 goes into both 6 and 9, and I divide it by 10. So you're going to have 2/3. Once you know those are not equal, you don't even have to worry about the last one. Okay, but all of these are not equal to each other. Okay, so your solution is just no, your ratios are not constant. we're going to move on to example 3. So it says for parts A and B, if there's more than one answer, just indicate what the first term is and the R value is for each one of those solutions. So sometimes we're going to get more than one value, so we're going to look at that case. Other times you'll only have one value, so it just depends on your setup. So this one here is asking you to find the 7th term of the geometric sequence, and they give you a sub 4 and they give you a sub 5. Okay, now they gave you 2 terms that were right next to each other. That is not always going to happen. If they do give you 2 of them that are right next to each other, you can just divide. What's negative 4 divided by negative 8? 5. Okay, so for one like this, you can absolutely do that. If you have ones that are further apart, then you can apply the given equation. A sub n equals a sub 1 times r to the n minus 1. And you can solve to find r. Okay, so if I'm given a sub 4 and a sub 5, just like we learned yesterday, you can plug in anything you want for the a sub 1 and the a sub n. I always put the larger one here, so I don't have to deal with a negative exponent. So if I plug in a sub 5 and a sub 4 times r, n minus 1 becomes 5 minus 4. Okay, so a sub 5 is negative 40, a sub 4 is negative 8 times r to the first, which is just r. Okay, so then your r value is going to be 5. All right, and then we are going to find our a sub 1 value. Okay, so to find the a sub 1, you can plug in anything you want into this equation. So I would either plug in a sub 5 or a sub 4, it doesn't matter which one. But now you want the a sub 1 in your equation, so you can solve for that. You know that your r is 5, and then your n minus 1 is just going to be 4 minus 1. So your negative 8 equals a sub 1 times 5 to the third. Okay, we know that's 125, so let's just divide both sides by 125. And that is going to be your a sub 1. Okay, you can't reduce that at all. Okay, and then we're going to write the rule and evaluate. So the rule is your a sub n equation. So your a sub n is going to be a sub 1, which you just found, negative 8 over 125, times your r value, which is 5, to the n minus 1 power. Okay, so this is your rule for the nth term. Okay, and then we are going to evaluate for what they're asking us to find, which is the 7th term. So we're going to find a sub 7. So that's negative 8 over 125 times 5 to the 7 minus 1. Okay, so negative 8 over 125 times 5 to the 6. Okay, if I made you do this without a calculator, can you guys think of a strategy that would make that easier for us to do? Okay, so negative 8 over 125 times 5 to the 6. Okay, so negative 8 over 125 times 5 to the 6 is negative 8 over 125 times 5 to the 6. Okay, so negative 8 over 125 times 5 to the 6 is negative 8 over 125 times 5 to the 6. Okay, so negative 8 over 125 times 5 to the 6 is negative 8 over 125 times 5 to the 6. Okay, so negative 8 over 125 times 5 to the 6 is negative 8 over 125 times 5 to the 6. Okay, so negative 8 over 125 times 5 to the 6 is negative 8 over 125 times 5 to the 6. Okay, so negative 8 over 125 times 5 to the 6 is negative 8 over 125 times 5 to the 6. Okay, so negative 8 over 125 times 5 to the 6 is negative 8 over 125 times 5 to the 6. Okay, so negative 8 over 125 times 5 to the 6 is negative 8 over 125 times you write 125? 5 to the third. So if this is 5 to the 6 and this is 5 to the third, it's just negative 8 times what? 5 to the third. So negative 8 times 125. Do you know what 125 times 4 is? 125 times 4? 500. So 500 times 2? 5,000. Okay, and so 8 to the 7th is negative 1,000. And then we are going to be using our calculators for part B. And really, I would like to use that on part A as well. But I'm going to have 2 parts for your assessment. So in this one, they're asking you to find the 8th term of the geometric sequence. And they give you a sub 3 and a sub 5. So these are not right next to each other. They are just a space apart. But let's see if we can find the common ratio. I'm going to write just the general equation here. And then I'd like you guys to write what you're going to plug in for the a sub n and the a sub 1. And then let's see if we can solve that. So remember, you were just replacing the a sub n and the a sub 1 with what's given. So what are the 2 things that are given to you? A sub 3 and a sub 5, okay? So it honestly doesn't matter which one you plug it into, but I like to take the larger term first. You guys know what that is? What I'm trying to avoid? Yep, I'm trying to avoid the negative exponent. Okay, you can have one. You can still solve it. You know how to do that, but I am avoiding that. So now I can plug in 324. A sub 3 is 36 times r squared. So we're going to solve for r. And then, Lauren, divided, what did you get? Oh, okay. Great. Okay, and then to solve for r, what do I have to do to both sides? Square root. So when you have a square root, what do you have to put in front? Plus or minus. So double check that you have the plus or minus. So this is one of the cases where you're going to have 2 solutions here. Okay, and so when that happens, you have to consider both the positive and the negative values. So we're going to find a sub 1 for both cases. Sometimes it's going to be the same, sometimes it will be different. So for the positive case, you're going to substitute in r is equal to 3. And for the negative case, you're going to substitute in r is equal to negative 3. Okay, so with our equation, You can plug in either a sub 3 or a sub 5 to start. It does not matter. Okay, and then if you use 3, you would do 3 minus 1. If you use the 5, do that to the 4th power. Okay, so a sub 3 I know is 36. And then 3 squared is going to be 9. I'm just going to divide both sides by 9 to find that a sub 1 is 4. Okay, now your solving process is going to be very similar here. Okay, so the only difference is now instead of positive 3, you're going to have negative 3 when you substitute. But because of our properties of exponents, when we square negative 3, we still get a positive 9. So in this case, the a sub 1 is the same. Okay, that's not always going to happen. It depends on what your exponents are. And then in our last step, we are going to write the rule and evaluate for a sub 8 because it asks us to find the 8th term. Again, we consider the positive and the negative values. So in the positive case, our r is 3 and our a sub 1 is 4. In the negative case, our r is negative 3, a sub 1 is still 4. Okay, so we are still going to be substituting into that general equation for geometric, but we are going to find a sub 8. Remember, it's a sub 8 times a sub 1 to the value of r to the 8 minus 1. So we know a sub 1 is 4. We know r is 3. So we're going to calculate 3 to the 7th times 4. And then, Jaden, when you have that final answer, will you let me know? Jaden. Great. So this is how we're going to write our answer. A sub 8 is 8,748 when r is 3 and a1 is equal to 4. Okay, so this is if you have two different answers, you identify your r and your a sub 1 value. So in the negative case, we're doing a sub 8. Remember, this is going to be the same thing, except now you have a negative. Okay, if you have a negative to an odd, this becomes a negative times 4. So we've already done that calculation. Just know that the answer is going to be negative now. Negative 8,748. And that happens when your r is negative 3 and your a1 is 4. Do you guys know why you have two different values for this? Why we can't decide which one it will be based on what we're given? So we're given these two values, 36 and 324. Okay, so our r is 3 or negative 3. Because if you multiply by 3 twice, you get 324. Mm-hmm.
I was just going to say,
Exactly. So when you multiply the negative by the negative, because they're two apart, you still get that positive value. So we can't decide with what we're given which one it is. Okay? So times 3 makes 324, times negative 3 times negative 3 also makes 324. Okay? If they're one apart, you know. Alright, now we are going to do some partial sums for geometric sequences. Yesterday we did those with the arithmetic. So we still have the s sub n notation for the partial sum. But you take the first term, a sub 1, and you multiply that by 1 minus r to the n over 1 minus r. Okay, and we'll see in your book that they do stipulate this is where the value of r cannot be 1. Because remember, 1 to any power is just going to be what? 1 to the first, 1 to the second, 1 to the negative second. You always get what? 1. Okay, so in our first one, it just says find the sum. Okay, and so what we can do is find the common ratio based on what we have. We have a sub 1, a sub 2, a sub 3. Okay, I'm going to show you how you can use the equation, but once like this, you can just write out what your r value is, because you can see right away that you're multiplying by what number? 2. Okay, so your r is 2. And once you know what that is, then you can find the n value, because we want to know how many terms this is. You could just keep multiplying by 2 and figure out what term that is, that's fine. Or you can use your equation. Okay, so there are ways you can figure it out logically without using the equation. And I don't mind which method you use as long as you just show me how you did it. Okay, so for this equation, your a sub n value, we know a sub n is the last term. So our last term is 256. So we can plug that in for a sub n. We also know our a sub 1, and we know our r. So if I'm going to solve this, 1 times anything is itself. How do I undo an exponent? What's the inverse of an exponent? The log. So we got to take the log of what? Sorry, some of you are very sad. Yeah, just take the log of base 2, right? So if you take log base 2, and you have n minus 1 equals, and when you're calculating this, you could calculate this without your calculator. You just have to ask yourself, 2 to what power is 256? And a lot of you probably know 2 to the 5th is 32. So 2 to the 6th is 64. 2 to the 7th, 128. 2 to the 8th. Yes, yes, yes. So it's going to be 8. So then when you add 1, you know that the value of n is 9. Okay, so there are 9 terms. Okay, if you wanted to keep multiplying by 2, you would just demonstrate that, right? A to the 4th, A to the 5th, A to the 6th, 7th, 8th, 9th. And now we can find our sum because we know what our value of n is. We can find s to the 9th. Okay, so s to the 9th is going to equal our first term, 1 minus r to the nth over 2. Okay, and we just talked about 2 to the 8th was 256. So what's 2 to the 9th going to be? 512. Double 256, and you just divide it by negative 1. So this is going to be 1 minus 512. Oh, it's not like, yeah. Yes, yes, yes. So it is 600 by the negatives, be a positive 500 and L7. Alright, now, when you are given a value with the summation symbol, ones like this, when you are doing your assessment, are going to be no calculator. Otherwise, you could just do what? calculator, just your summation. Okay, so ones like this are going to be no calculator. And keep in mind, when you are doing that without your calculator, this is now the equation we're going to be using. 1 minus r to the n over 1 minus r. So in order to use this summation equation, we need three variables. We need a sub 1, we need r, and we need n. Okay, so we can find a sub 1 by plugging in whatever value is in the on the bottom here. I'm going to say denominator, but it's not a denominator. So whatever you start with, whatever the starting value, that's what you're going to use. Okay, so a sub 1 would be 1 half 1 minus 1. So to the 0 power, it's always going to be 1. Anything to the 0 power. Okay, in our second step, we are going to find the value of r and n. Okay, if you have this in the form of a sub 1 times r to the n minus 1 or k minus 1, you can pick out your r right away. You don't have to do any work for that. But sometimes you don't have the k minus 1, you just have the k. And I want you to be mindful that sometimes you're going to have to find the second term. So if you find the a sub 2, in this case we started with 1, so you're going to plug in k is 2 to find that. We have 1 half to the 2 minus 1, which would be 1 half. And then you can calculate r by doing the second term divided by the first term. Okay, in this situation, you would be able to just see it here, but not every situation is going to be like that. Okay, this you can use anytime. Okay, so this is going to be your r value. So if the equation is in the form a sub 1 times r to the n minus 1. Okay, you can identify it right away. You don't have to do any work. If not, you find your a sub 2, divide that by a sub 1, and that will be your r value. Alright, and then remember that the value of n is equivalent to the number of terms. So if you have a summation notation, you can just do 6 minus 1 plus 1. Okay, so that's your value for n. And now that we have all of those, you can use them to calculate the sum. Okay, so we have s sub 6, our a sub 1 is 1, 1 minus our r value is 1 half to the power of 6 over 1 minus 1 half. Okay, so 1 minus r to the n over 1 minus r. So 1 times anything is itself, so we really don't have to worry about that. 1 minus a half, we know it's 1 half. Okay, and then we're going to do the exponent here. So 1 to the 6 is 1. What's 2 to the 6? What's 2 to the 6? So how many 64s do you have left if you do 1 minus 1 over 64? 63. Okay, and then what we have here is just division, right? The division of fractions. And you change it with, and if you're doing that without your calculator, I would just recommend reducing at this step, because 2 goes into 64 how many times? 32, and then you just have to multiply across. So 63 over 32, that is going to be your sum. Okay, so when you're practicing, anytime you have the summation, unless it says choose a calculator, practice that without it. Okay, and then the last thing we are going to learn today is how to find the sum of an infinite geometric series. So sometimes we can find the sum, other times we can't. It all depends on the ratio. So if the absolute value of r is less than 1, then what happens is this series converges and it does have a sum, and this is the equation. S equals A over 1 minus R. Okay, or remember yesterday I said A is equivalent to A sub 1. That's what we're going to use. Okay, so if it's less than 1 is the absolute value, it's going to be some type of fraction that's less than 1. So like if you keep cutting something in half, eventually it gets so small that it rounds to what number? Keep cutting something in half. It rounds to 0, right? That's why we're able to find what the sum is. But if it's bigger than 1, then you can't find it. If you keep multiplying by 2 to infinity, okay, that goes on forever. We say that the series diverges in that case, and we will not be able to find the sum. Okay, so what I just told you, I organized here for us. So when it approaches a fixed number, when the absolute value is less than 1, okay, it approaches some fixed number, and that's why we say that it converges, because it converges to that number. Okay, this value has a special name that we're going to talk about in chapter 13. It's also something you will study if you go into calculus. The number it approaches is called a limit. Have you heard of that before? A limit? Okay, we're going to explore that more in the next chapter. And then, if you have the absolute value is greater than or equal to 1, so even if it is 1, okay, I can't add up 1 to infinity, right? It keeps going. So it does not approach a fixed number, and that's why we say it diverges. Okay, cannot calculate it. Okay, so you are going to determine whether each geometric series converges or diverges. If it converges, you're going to find the sum, and if it diverges, you're going to write an inequality that explains why. Okay, which is just the definition of what happens. Alright, so this all depends on what your value is for r. So all we have to do is calculate the r values. Now this is alternating, so if there's a negative in front, you have to take it with it. So we have negative 0.2 over 1. Okay, so this is our value for r. And then we're just going to compare the absolute value of that to 1. So since you have negative 0.02, if we take the absolute value, we have 0.2. That is going to be less than 1. So the series converges. If the series converges, we have to find the sum. This one without your calculator. Okay, go ahead and calculate that. Don't have a decimal in a fraction, so think about how you can simplify that. Alright, what do we get for our sum? 5, 6 is right. Okay, so when you're plugging this in, when you get your decimal, minus the negative is going to be plus. So we have 1 over 1.2. Okay, and then we don't want that decimal in there, so we just multiply by 10 over 10. So we get 10 over 12, reduces to 5, 6, and that is your sum. Alright, and then what did we get for our R for B? Did we do that already?
Yes.
Okay. Great. Okay, so if you have that value that is greater than or equal to 1, all you have to say is this. Since the absolute value 3 is greater than or equal to 1, the series diverges. Which always makes me think of the Divergent series now. The book, did you guys watch that? Was that popular when you guys were growing up? Divergent, Insurgent, whole bunch of gents in the series. Alright, so, you can choose if you want to work on part of your review or your homework today.